Now let us consider one more example to see how an inequality, how we solve an algebraic expression in inequality. Let us write this minus 5x plus 3 less than 7 by 2. Now here I deliberately took a negative value attached to x. Let's see how the final solution looks like. So when we are moving 3 to the other side, inequality obviously will not get affected, plus 3 move to the other side, it is minus 3, minus 5x less than, so 7 minus 6 by 2, so minus 5x less than 1 by 2. Now the discussion comes about moving minus 5 to the other side. Now when we are moving minus 5 to the other side of the inequality, what happens to the inequality? It's a negative value which we are moving. So obviously the inequality reverses and minus 5 comes here, 1 by 2 into minus 5. Here which is in the multiplication would come to the denominator, obvious, which we already know, but what happens to the inequality? It reverses. X less than minus 5x less than half now becomes x greater than 1 by 2 into minus 5, which means x is greater than minus 1 by 10. So if I draw a number line, writing minus 1 by 10 somewhere here, talks about all the values of x. The values of x are something which is strictly greater than minus 1 by 10. It talks about this region, the values in this region. So it goes till infinity. Anything greater than minus 1 by 10 is a value of x. So how would I denote the answer for this? X belongs to minus 1 by 10 to infinity. So these are the values of x. X is a value greater than minus 1 by 10. So x belongs to open bracket minus 1 by 10 to infinity. Infinity is always considered with an open bracket, but what about minus 1 by 10? Since the solution says it is strictly greater than, we have x with an open bracket at minus 1 by 10. Now we will look at something more interesting in solving this inequations. What is an union and what is an intersection? Where do you consider union between two solutions and intersection between two solutions? For example, I give you an expression like this, minus 3x plus 2 less than 5 or less than 11, and this is an and statement. I think you understand what an and statement is, and 5 minus 7x greater than or equal to 4. So there are two inequalities simultaneously given where the value of x satisfies this as well as this at the same time. So x satisfies this inequality as well as this equalities, because and is a very important thing, which means when you say and, both the conditions are satisfied. When you say or, any one of the conditions must be satisfied by x. Now when I am saying and, x satisfies this condition as well as this condition. So let us solve these two inequations separately. Let's see what happens. Minus 3x less than 11 minus 2, 9. So x will be what? Greater than or less than 9 by minus 3. What should we consider here? So x obviously would become greater than 9 by minus 3. The inequality will reverse because you are shifting a negative value to the other side, which means x is greater than minus 3. This is what is the value of x which we are getting by solving the first inequation. Let us solve the second inequation. Now I will move 4 to this side and I will move 7x to this side. I am just moving the entire minus 7x to this side. I am doing additions and subtractions. I am not doing any multiplication here. So the inequality remains unaffected. 5 minus 4 is 1 greater than or equal to 7x. Or if I write 7x is less than or equal to 1. So if I write 7x here, 7x is less than or equal to 1. So what is x? Less than or equal to 1 by 7, because we are moving a positive value to the other side, the inequality remains unaffected. So x is less than or equal to 1 by 7 is the second solution. Now what is x? He says x is greater than minus 3 and x is less than or equal to 1 by 7. So both the conditions should be satisfied. How should I ensure both the conditions are satisfied? That is important. So I'll mark this first of all minus 3 on the number line. I will also mark 1 by 3 on the number, 1 by 7 on the number line. Okay, remember one thing, this is a negative value, 1 by 7 is a positive value, so it comes to the right of minus 3, which is greater than 1 by 7 is greater than minus 3. So a value which is greater will be on the right side, the smaller value will be on the left side of the number line. So minus 3 is on the left, and 1 by 7 is on the right of the number line, correct. Now let us consider the region indicated by x greater than minus 3. I will use a horizontal line. So this is the region indicated by x greater than minus 3. Everything towards the right of minus 3. And x less than or equal to 1 by 7. So when I draw a line here, everything less than 1 by 7, when I say less than 1 by 7, to the left of 1 by 7, everything towards the right of 1 by 7 is greater than 1 by 7, everything to the left of 1 by 7 is less than 1. And let me draw these slanted lines. So how do we conclude x? How are we going to conclude x? The value of x satisfying both the conditions is the region where you have both the horizontal lines as well as this slanted lines. This is the region that we are talking about between these two, where x satisfies both the conditions. If you look at this region, x is satisfying only this condition. It does not satisfy this condition. If you look at this region, x is satisfying this condition, less than 1 by 7, but greater than minus 3 condition is failing. So what is the value of x where both the conditions are satisfied? It is this particular region on the number line where these two conditions are satisfied. So I can finalize my solution as minus 3 to 1 by 7, smaller to the bigger value, the extremes, minimum to the maximum, and what bracket should be used here to finally conclude the value of x. So x is strictly greater than minus 3, so open bracket. X is less than or equal to 1 by 7, which means close bracket. Why? Because the final value of x can also include 1 by 7. So when you can include the final extreme, you use a closed bracket. So this is the solution set for these two inequations, minus 3x plus 2 less than 11, 5 minus 7x greater than or equal to 4. So this particular condition, this connectivity is very important. How are these two inequations connected? Using an AND sign, which means x satisfies this inequation. At the same time, x also satisfies this inequation. So the values of x satisfying both the conditions at the same time is this region. Both the conditions are satisfied at the same time. So you solve for this inequation, solve for this inequation, see the common values of x satisfying both. That's it. That is what this means.